So again, today, Chapter 3, the essentials of JavaScript statements. Most of them are going to be conditional statements, loops, arrays, stuff that we've already covered in C#. Let me go ahead and stream this for you if you want to watch it on your Discord. There you go. So, objectives, part 1, given the specifications for a JavaScript application that requires only the skills you've learned so far, code, test, and debug the application. Describe the rules for evaluating a conditional expression that consists of relational operators, including the use of the is NaN, which means is not a number method. Describe the use of the logical operators and the rules for evaluating a compound conditional expression, including order of precedence and the use of parentheses. Describe the flow of control for an if statement that has both else if and else clauses. Describe 2 ways that you can code a conditional expression that tests whether a Boolean variable is true. Describe the flow control for a while, do while, and for loops. Describe the use of a JavaScript array, including the use of indexes and the length property of an array. Describe the use of a for in, and for of loop for processing each element of an array. Like I said, a lot of this just goes back to C# stuff that we've already learned. And I said in the past, once you kind of learn one programming language, a lot of them kind of flow into another. If statements are always if statements, for loops are always for loops, that kind of stuff. Boolean is always checking for a Boolean kind of a thing. So none of this is really going to be new to you. So the relational operators, the double equal sign is equal to. So when you're comparing 2 values, you use the double equal sign, not the single equal sign. The single equal sign assigns a value to something. The double equal sign is comparing 2 values together. The exclamation point and the equal, again, is the not equal to, greater than, and the less than. What's it? The open mouth of the shark or alligator always goes to the larger number, something like that. Greater than or equal to, less than or equal to. Here's some examples of conditional expressions. Last name is equal to Hopper. Test score is equal to 10. First name does not equal Grace. Months does not equal 0. Test score greater than 100. Age is less than 18. Distance is greater than or equal to the limit. Stock is less than or equal to reorder point. Rate divided by 100 is greater than or equal to 0.1. Like I said, this is all stuff we covered in C#, so you should be pretty familiar with it. The syntax of global is not a number method, is not a number, and then the expression in the parentheses. So what you're doing is checking to see whatever's in this parentheses if it's a number or not. So this first example is not a number, and they put Hopper in there. Well, Hopper is not a number, so it returns true because it's checking again to see if it's not a number. If it's not a number, it's true. If it is a number, it's false. So the second one down here, 123.45, returns false, which seems odd to me because with the parentheses around it, you'd almost think it would be a string value that you're putting in there, but they're checking for the numbers, so that's why it ends up returning false. Logical operators, and again, same as what we did in C#. The double ampersand signs stands for and, returns a true value if both expressions are true. So the left side and the right side both have to be true for this to be valid. The operator only evaluates the second expression if necessary. So if the left is valid, that's good enough. They won't do the second side. So then you have the double pipes, the or, returns a true value if either expression is true. This operator only evaluates a second expression if necessary. So if one or the other is true, that's good enough. It won't have to do the second one if the first one ends up being true. And then the exclamation point is the not, and we saw that with the not equal, not greater than. I guess you wouldn't use not greater than, but not equal to. Reverses the value of the Boolean expression. Conditional expressions with logical operators. Example 1, the AND operator. Age is greater than 17 and the score is less than 70. So it's checking both the age and the score to make sure they're true. So if the first one is false, it doesn't have to worry about checking the second one. Example 2, the OR operator is not a number rate, or rate is less than 0. So if that rate is not a number, or the rate is less than 0 is what it's checking there. And in example 3, the not operator, if it's not is not a number age, and then it would pass validation. That's kind of a weird way to set it up. Not is not a number. That just kind of looks odd. But the order of precedence for logical operators, the not operator first, AND operator, and then finally the OR operator. Terms related to conditional expressions, conditional expression, relational operators, compound conditional expressions, logical operator, order of precedence, and short circuit operator. Syntax of the if statement, and again, like I said, this is just all a refresher of C# that you guys have taken already. If one condition does the statement, else if a second condition does the statement, and so on and so on. As it runs through the conditions, the very last one is kind of a catch-all with the else, and then you put your statement in there. You write them the exact same way we did in C#. Start out with your if condition statement right there. You have your if statement, you have your condition inside the parentheses, just like we did in C#. So they're saying if age is greater than or equal to 18, if that's true, drop into this first set of curly brackets, throw the alert, you may vote. If that's not true, if this if statement, age is greater than or equal to 18 is not true, then it will drop down into this else and then do the alert, you are not old enough to vote. So exact same way it works in C#. If it's true, it drops down and does the first line right after the condition. And if it's false, it goes to the else and does what the else says. If there's else ifs in there, then it will pick up the else ifs and check those conditions first. An if statement with else if and else clauses, and that's just what I was saying. If is not a number rate, so if they put a rate in of Dominic, that's going to pass that. And then alert, you did not provide a number for this rate. If it is a number, it can go down into the else if and then say rate, check to see if the rate is less than 0. If it is less than 0, then it'll show the alert here. The rate may not be less than 0. That's not the case though. If the rate happens to be greater than 0, it'll go down to the next else if statement and it'll check that rate there, and if that rate is greater than 12, so if the rate's 13, it will drop down into this alert here and catch that the rate may not be greater than 12, else alert the rate is, and what they're doing here is some concatenation. This is the string, the rate is colon is part of a string, and then they put that variable, the rate, in there to display it in the alert. And like I said, day before yesterday maybe, that back in the old school way, that was how we did a lot of our value debugging, was throw alerts like that with some text and the variable value in there, so you could kind of see what your values were coming back as you tested it to make sure your code was running right. So this just if statement with else ifs and else, like I said, exactly like C#. Set it up, run it, it works just like C#. So you have your if, it does your check. And again, this is not a number. That is not a number is checking to see if it's a number or not. Is it a number? Yes, it's good then. If it's not a number, then it's not right. So then it drops down into the alert and just kind of keeps walking through the statement. An if statement with a compound conditional expression. So they're doing an if statement, and then they're doing an and or an or inside the if statement. That's all that's saying right there with the compound conditional expression. So they're saying if is not a number, user entry. So if they put, again, Jason in there, that's not going to pass. User entry is less than or equal to 0. So if they put a negative number in there or a 0, it's not going to pass. And so then you'll get that alert if one of the two are true, though. So see how it tests a Boolean value, see if it's true. Let's go back to this again real quick, though. So if is not a number, in user entry, we put, like I said, Jason in there, or we put a negative number or 0 in here. Because these are both true, either one of them would be true in that case. The first thing it's going to do is drop down into that alert and say enter a valid number greater than 0. So that's what it's checking. This first one's saying, is it a number? Well, we're putting a name in there so we know it's not a number. So that would say true, it is not a number. Drop it into true. Or if we put a number that is less than 0 or 0, that is also true for this little statement here, and that would drop it into the true. Does that make sense how that works? It's kind of a little bit confusing, but I think if you work with it a little bit, it'll make more sense. How to test a Boolean value to see if it's true. If is valid equals true, do something. Or you don't have to have true. If you just put is valid, it automatically checks for the true if you leave that equals true off of there like that. So somewhere in your code, you'd probably set is valid as a variable, set it to true or false, and then as you're running through here, you'd check your if statement to say, is it valid, depending on what happened in your code. And again, you can set it up as equal true for the check. Or you can just leave it is valid, and that's when you do that, just is valid by itself, it's the same thing as doing the equal true. So a little bit of a shorthand can save you a couple seconds of typing. Again, to see if it's false, you can do is valid equals false, is valid not true, or not is valid. So that not is valid is same as what the line above it saying not is valid equals true and is valid equals false. So it's a couple different ways to write it. To me, that is valid equals false is probably the more clean way to actually read it, especially if you're new at coding. Once you get doing it for a while, you can use the shorthand method of that not is valid. Sometimes, though, like I said, when you're first starting out coding or fairly new to coding, that can get confusing to you. So if you want to stick with that is valid equals true, that's fine. Seems like a lot of times when you look through code, you'll see it like the top lines here. This is true and the false, just because it's a little more clean, a little more easy to read, but you do see it as this is valid a lot of times too for the true statement. Don't see it quite as much for the not, but I'm sure a lot of people still do use it. The syntax of a while loop, again, the while, the condition, and then the statement you want it to run. So an example here, they create a variable, let, name it sum, give it the value of 0, let I equal 1, and so they're saying while I is less than or equal to 1, or less than or equal to 5, I'm sorry, take the sum and add the 1 to it, because we give it the 1 up here in this I, so we know this I is a 1, we know this I is a 1, and so it says take this I, which is a 1, and add 1 to it. So it's going to go through it it says alert the sum, and the sum ends up being 15.
Because you're incrementing it, aren't you?
Yep. So while I is less than or equal to 5, it's going to keep looping through it, and then it'll keep adding, and then when it drops down to the end, it does the alert, sums them up, and that's what your 15 is. A while loop that makes sure a user enters a positive number. So let years, declares the variable, years is the name of the variable, and then they assign this value of %, prompt, enter number of years, and again that % is just making sure you don't put like a decimal number in there, because % will strip the decimals off. So if you put like 10.3 years, it will strip that 0.3 off and just put it in as a 10. So what they're doing here is saying while is not a number of years, or years is less than or equal to 0, and that's exactly what we looked at earlier, pretty much right here. They're saying it's not a number of years, so if you put something besides years in there, or you put a negative number or a 0 in there, it's going to be positive and drop down into this here and then throw the alert, because it statement ends up being true. So if is not a number, if we put Doug in there, that's going to be a true statement and drop it down in here. Or if years is -1 or 0, it'll drop down in there, since that's also a true statement. So syntax of a do while loop: do statement, while, and then your condition. So here they're declaring a variable let, giving a name of years, and the value of it is null. So in your statement, you got your do statement here, and says do this, which is years equals %, prompt, enter number of years, must be valid positive number. And what was that, Tuesday, when we looked at the prompts and the alerts and stuff like that, that's all this is a prompt that's prompting you to put a value in there. And then it says while is not a number of years, or years is less than or equal to 0, keep doing it. If it's not true, then go ahead and break out of the loop. We used these a few times in C# while we were doing some of the, I think where you could add like test scores and stuff like that to them in some of the earlier chapters. Syntax of a for statement: for, and then you have your loop that you go through, the condition for it. The counter initialization is the first thing you check, then the condition, and then you increment the expression, and then you have your statement inside the curly brackets. Again, same thing that we did in C# with for loops. So here they're saying declaring a variable let, giving it a name of sum, or giving it the value of 0, assigning the value of 0 to it. And they say for let I, and the reason they have this let I in here is because they're declaring that variable inside that for the counter initialization. You could put it outside the loop if you want to and do it up there, but here they just do let I equal 1, as long as I is less than or equal to 5, run our code, and then come back through and increment it each time. Then the alert at the end, once it runs through the loop the proper number of times, it comes down to the alert, and it displays the sum as that sum keeps adding up, and it displays the number 15. So again, just a typical for loop, exactly what we've been using this whole time that we did C#. For loop that calculates the future value of an investment. Here they have a constant variable called investment equals the value of 10,000, a constant with variable with the name of annual rate. They assign it the value of 7.0. Same, constant years is 10. Here they do let future values equal investment. So this future value is going to equal investment. So let I equal 1. I is less than or equal to the years. Increment it. So it drops down to here, future value. You add the future value to it. Times the annual rate. Our annual rate appears 7, and you divide it by 100. And the reason you divide it by 100 is to get the percentage for it. So if you're trying to work with percentage rates, you're probably more than likely going to have to divide by 100 to get that percentage rate right. So it keeps looping through here for the number of years. It looks like the number of years is 10, so as long as it's less than or equal to the number of 10, it'll keep looping through here. If it hits 11, it'll stop, and then it'll alert your future value to fixed. They're saying they don't want any decimals with it, with that 2 fixed. Remember talking about that Tuesday? And so then it's going to display 19,672 as the value. And here they declare this future value and assign it the amount of the investment. Because this investment is a constant, it always stays at 10,000. Well, we know we're going to change this future value, so that's why we assign that investment to it. So we know we can go ahead and change that as we keep incrementing through it. Other ways that the future value calculation can be coded: future value equals future value plus future value times annual rate times 100. And again, this is in parentheses, so that part would run first before it adds it to this future value over here. And then future value equals future value times, and then in parentheses plus 1, and then in parentheses the annual rate divided by 100. And again, like I said, to get that percent, you have to divide it by 100. So that's what they're doing here, is dividing it by 100 first before it does anything, because it's inside the parentheses. And then it does the next one that's inside the next set of parentheses, and then it'll finally multiply it by the future value there. So a little bit shorthand way of coding it out, a little bit different, but it all works exactly the same way. A for loop that increments the counter by 2. So we'll do for, let I equal 0. I is less than or equal to 10. When we loop through it, instead of going one at a time, now we're going to jump it up to 2 since we're doing this plus equal 2. So document.write, and again, when we talked Tuesday, this document.write object, document object using the write method, is going to write this out to the screen each time we run through it. And so as it goes through the first time, it'll be 0, and then it'll print it again at 2 after it increments, and it'll increment again to 4, and so on, and give us our display of 0, 2, 4, 6, 8, 10. A for loop that decrements the counter, and then we have a for. Same way, we can declare our variable to let I equals 3. I is greater than 0, subtract 1 off of the counter. Document.write, they just got the value here, and then whatever they're putting here, it looks like blast off eventually. Blast off displays 3, 2, 1, blast off. And Monday when we get back from our weekend break, I'll code some of this stuff out for you guys just so you can get a little bit better idea what's going on. Jason, you probably understand it pretty well. Dominic, I look at you and I see maybe a little.
Yeah, I'm a fan for the binding bar. Checking out that homework, JavaScript, the first one.
Yeah.
Even though I think I see what's going on, I think I know kind of partially the answer.
Okay.
So what's going to probably happen is, so I'm going to be using like HTML and JavaScript at the same time, right? But also I'm using like the HTML form, and then probably doing some type of like calculation, but I'm only having more like a constant, more like 2.
Yeah, so we'll take a look at it after this, and then like I said, Monday we'll take a look at some of our labs and stuff, and we'll code a couple of them out just to help you get a little bit familiar with some of this stuff as a refresher from your C# days that were so long ago. And then here's an example here. I think you do one of this in your first labs, don't you? Something this mile per gallon calculator.
I haven't looked at the first lab yet.
Yeah. So here's a little more in depth. The prompt dialog for continuing the mile per gallon application, and it says continuing. So yeah, I'm guessing this is part of your chapter 2 labs or homework that you're going to do. And you can just see page repeat entries, yes or no. And you can put yes if you want to keep repeating. And then it calculates miles per gallon in the browser. So you'll probably be using like a do while loop here. So and I'll probably give you the code for it in here somewhere. Yeah, so here you go. So here's your do thing. Again equals y. So you're saying in this prompt you're asking if they want to repeat entries. So this yes or no kind of tells you it's going to be a do while loop, because you want it to keep doing it until they say no is what you're looking for in this. So you can see they do again is yes, do, and you run through it the one time, and they're saying the constant miles equals %, and that %, they're setting up this prompt where it says enter miles driven, and then the gallons, % prompt, enter number of gallons used. And I think we did an a lab like this back in the C# days.
Yeah, we did.
Yeah, so inside this do, they do an if statement where it says if miles is greater than 0 and gallons is greater than 0, the MPG, miles per gallon, parse float is miles divided by gallon. And the reason they use that float here is because this might end up being a decimal place here. So they want to get that decimal with it. And again, you can see they got some constant HTML here. And what they're doing here with this constant HTML, we haven't really seen anything like this yet, is they're taking a variable, it's a constant, it's HTML, and what they're doing is putting, and you can see the little tick sign here, that's the key to the left of your number 1 key on your keyboard. And so what they're doing here is putting that in that little tick, and then doing a paragraph just like we do with HTML. It's an HTML paragraph is what this is. And then they're using the $sign here.
Strange relation.
Yeah, something like that. It's not quite called the same thing, but yeah, you're on the right path with that. And we put miles here, so it gets this variable miles and puts the value in there. It says miles on, and same thing with the gallons. And then you get the gallons. And then you take that MPG to fixed, and again that to fixed is 2 places, 2 decimal places, and that shows how many miles per gallon you get. And again, since this is HTML, we open this paragraph, we have to close the paragraph down here. And this document.write, what this document.write is doing, it's going to write to the page like we saw Tuesday. And it's going to say document.write, take this variable HTML and print it out. Well, this variable HTML that we created, we put this HTML in it. And so this HTML will print out is what it's actually going to do. And then else, alert, one or both entries are invalid. Again, equal prompt, repeat entries, yes or no. If it's yes, keep repeating while it's yes. And so we can take a quick look at this if you guys want to. Let me go file, folder. So we'll go file, new file. It's called mpg.html. Get our thing going here. We'll go ahead and put our script call in here. Close my script for me. And so that's all we should need there. And we'll call it what, npg.js. So in here, with this being a JS file, we don't really have to do anything. We could do that use strict if we want to. Word. So then we'll do our let again equal y. We're going to do constant miles equals parse int. Prompt enter miles driven. Oops. Gallons equal parse int. We want to prompt the user each time to put a value in, is what we're doing here. Enter gallons of gas used. If statement, and again, like I said, this is going to be just like we do in C#. Here's our conditional statement. We're just checking to see if miles is greater than 0 and gallons is greater than 0. If it is, parse floated. Equals again, the P is an HTML element that we're going to use the write to the screen to make it a paragraph. And I'll show you something when we're done with this a little bit. $, miles. Yeah, please. It'll be out on the video too, so once I save it and put it out on YouTube, you can have that as a backup if you need it. Gallons. Gallons equals. And 2 decimal places. Close our paragraph. write our HTML out. One or both entries. So again, this alert just going to throw up a little window saying, hey, you put some bad values in. Or again, here is telling us, do we want to do it again? So it brings that prompt back up. Entries, yes, no. Let's yes, go ahead and keep going. Finally, it's saying finish your while loop, expecting a while, so we'll put a while down here. So now when we run this, it should give us a prompt, ask us to enter miles driven, enter the gallons of gas used. Does a check here to see if we're putting proper values in. If we do, it does the math. It does the math, and then we'll create a variable called HTML, put some HTML code in it, display our numbers here that we entered, and our calculation that we figured out. And then we'll write it out to the page. And if we put a bad value in, it's going to catch it, hopefully, and tell us we put a bad value in it. Our prompt will come up a second time and ask us if we want to repeat it. We can say yes or no. If we say yes, it's going to keep doing it. If we put that in there, it's not going to agree with our statement we have here. And it will stop running. So let's save all of this. Go to our MPG HTML page, open with live server. As soon as it comes up, we should get a prompt. And we did. There's our prompt. It says enter miles driven, say 100 miles. Should get another prompt when we hit the OK button. There's our other prompt. We'll say 10 mile or 10 gallons. And here's our 100 miles on 10 gallons is 10 gallons or 10 miles per gallon is what we got. That's pretty bad. We must have been driving like a semi truck or something on gasoline. And the reason that worked like it is with nothing in our body is because we're calling this JavaScript file here called mpg.js. And in this mpg.js file we're creating our HTML in this little bit right here. So as you can see, we have a paragraph in there now. We can change this to an H1 if we want to. And we can save this and run it again, and it should be the same thing, but it'll be using an H1 now instead of a paragraph, since that's where we're creating our HTML code from. And now you can see it's an H1. If you wanted to add style to that, you could add style to it to change it to colors and stuff like that. Go back to our code real quick. We could always put another paragraph under here. Close our paragraph out. Oops, save that, go back and look. And there's our paragraph we added to it. So you can code your HTML out through JavaScript if you want to. And there may be times where you will have to do it. I know in my career of doing this that there were a lot of times that you may have to create some HTML on the fly based on some kind of check you're doing in JavaScript. I'll bring the code back up for you, Dominic. So there may be some kind of check you're doing in JavaScript that if it validates or whatever, you may want to put some certain HTML up, and you can just code it on the fly like that through the JavaScript. So kind of neat that you can do it that way. That back where it was, save it, and then as we go back and look, we can put, it should give us an alert here. One or both entries are invalid. That's because I put a name in the first one and it's looking for a numbers value in it. Let's refresh it. And then we can do 100, 10, and it should prompt us. I wonder why it's not wanting to prompt us for the, because I spelled it wrong, P-R-O-M-P-T. It's like, why would it not prompt us again? Now we should get our prompt. Do we want to add more? We say yes. Put no in there, and there's our, oh, it should actually work when you spell things right. So it just keeps looping through. Keeps asking if you want to add more and more until you say no. Once you say no, then it quits. Probably put something besides a no in there if we really wanted to. Put a Z in there and it should end, because it's all it's checking for is the Y, making sure there's a Y to keep repeating. If you put anything besides a Y in there, it will stop repeating. But it's always nice to prompt the user or let the user know what they can put in there to get the code to break. If not, if the user doesn't know what's going on, they may not know how to get out of it to where they just keep putting yes in all the time or just keep adding stuff or whatnot. So it's always nice to let the user know what they need to break out of some of these loops and stuff that we're using. So that makes sense, this little bit of code here, what's going on with it? Any questions or concerns on it?
Can I see your HTML for a second? So I can try to get that link set up. Thanks, sir.
Yep. So the only thing you need in this HTML is just make sure you add the script source of our JavaScript file. And that should be it. Because like I said, that body gets all populated through the JavaScript code that we wrote. Does that make sense?
That's it.
All right.
Wait, hang on, my data come back.
So yeah, as you're declaring these variables, when you use them again, so like miles and gallons, make sure MPG, and we use MPG down here, make sure your capitalization is correct, make sure the casing is correct, and then make sure you're using the proper variable there. So let me get back to our slideshow. So there's the future value calculator. You guys will end up working that too as your lab. These slides again are out in your repository, so if you want to go grab these slides or look at the slides and use these as an example or to help you get through your labs, you're more than welcome to. Here they're using multiple do-while loops. So there's 3 do-while loops in there. There you can see they do a couple document.writes. And again, you have to use that little tick there to do, like Dominic said, the string interpolation kind of a thing that we did in C#.
Yeah.
Here's test scores in a browser. Again, this is exactly what we did in C#. We did some of these labs in C#, where you enter however many scores. You use that -1 up there to end it. Code on how to do that. Syntax for creating an array, to move on from the loops in that, is just give it an array name, a new array, and the length. And again, this goes right back to C#. You pretty much, like I said, you learn one language, you can carry it over to most of the other ones. Array literal, you just give it an array name and the square brackets to let it know it's going to be an array. And a statement that creates an array is just constant, the name of the array you want to give it, and then the literal there with the brackets saying, hey, this is going to be an array. That way code knows it's an array with these square brackets, and it will know what to do with it. Syntax for referencing an element in an array, and this again goes back to the C#, is your array has elements in it, and the elements are gotten by an index, right? Remember the index? What's the index start at for an array?
0.
0. Index array always starts at 0. So that first element in the array, just like we did in C#. We have our declare, our variable, a constant, we'll call it tests, is our variable name. And we're saying it's going to be an array, so then when we have our tests and our values in here, we'll have a 98, 76, 84, and a 20. Again, these are elements in the array. To access those elements, we use an index. Our index starts at 0, 1, 2, 3. And so that's how we would access them, by calling those index numbers like that.
Do we have lists also in JavaScript?
Yeah, but you use the arrays, it seems like, more in JavaScript than you do the lists, because we don't return a lot of things with the JavaScript like we do with C# in that. So you'll end up using arrays more in the JavaScript part of it. So then if we wanted test 0, that would give us the score of 98 because we're accessing that 0 index there. And that's what they're showing here. The index was totals, or the array name is totals. Index 2 is the third element in the array, and it's 411, and second element in the array is 212.25. How to add values to an array using individual statements. And again, this is just like we did in C#. You declare your array here, give it a constant, name it totals, show that it's an array with the square brackets, and then we're putting the value of the first element with the index of 0 at 141.95, the second element with the index of 1 at 212.25, and then finally the third element, which is our second index, our index 2, is 411. Or you can just do one single statement and just put them all in there like that. And again, this is the same thing we did in C#. Nothing's different here than what we did in C#. Declare our variable as a constant, give it the name of totals, and we're just putting our values inside the square brackets. Element 1, 2, and 3, index 0, 1, and 2 to walk through it. Syntax for getting the length property of an array, whatever the array name is, and the length. Statement that gets the length of an array. So what we do here is just declare a variable of a constant, give it the name of count, and then we take our array called totals and the length of it, and then in this count value, or the count variable that we created, whatever the length of the elements in the totals are, it gets stored in this count. So how to add values to the end of an array. This totals is the array, totals.length, and then they do 135.75, so that puts a value of 135.75 at the end of your array then. That makes sense? Code that puts numbers 1 through 10 in an array. Again, pretty straightforward. A constant, give it the name of numbers, square brackets saying, hey, this is going to be an array. Do a for loop, let I equal 0, I is less than 10, walk through it, take our array numbers and put the value of I in there, and then keep adding it 1 to it each time it goes through, and it should display eventually 1 through 10 like it does down here. So they're doing a display string as blank, 4, let it walk through, getting the numbers.length, and just like C#, when we walk through an array, we use that length there to get the number for the array to walk through the array properly. So let's say display string, display each number I as we walk through it. This alert display string, so in the alert, when the alert pops up, it's just going to show the numbers 1 through 10. So this stuff's pretty straightforward. Like I said, we've been doing it for the past 80 days in C# for the most part. Code that puts 4 totals into an array, and again it's the same thing we just saw right here, doing the same thing. Create a variable constant, give it the name of totals, say it's going to be an array with the square brackets, and just put the values in for the 4. This sums it up, so they declare a variable let, give it the name of sum, assign it the value of 0, then it's going to do a for loop, go through it, as long as I is less than totals.length, and again our length is how many?
4.
Yep. Increment it, and then it's going to sum up the totals, so it'll take all these totals, sum them up, and store them in the sum. If you want to display it, you could do an alert and then put the value of the sum in there, or the variable sum in it, and it would show you what the total of all these are as they add up. And here they're doing it individually, and then they're going to print it out. So here they're doing creating a variable, it's a let, giving it the name total string, equal, and they're making it blank, so there's no value in it at the moment. Doing a for loop, loop through it, as long as I is less than totals.length, and we already saw that totals.length over here is 4. Go through it, so the total string, it separates each one out, and then alert the totals are total string plus a line break, and then the sum and the sum. So they're taking some of this code from over here, putting it on here to get this to display out. So if we took all 4 of these numbers, added them up, we'd get this 995 down here. And syntax of the for in loop. And this is just kind of how you can loop through an array for the index initialization of the array and then the statement you want. So it's saying let, declaring a variable, it's a let, name of its sum equals 0, the value is 0, so for let I in totals, sum plus totals is I, and then alert the sum. And again, this is just like exactly like C# when we did that for in loop with the arrays in C#. Instead of doing that for loop with the length and stuff like that, we just do that for let I and use that keyword in, and that keyword in gets out the values of that totals array that we keep creating from previous slides. They sum them up, and again that sum ends up being 900.95, just like it shows here when we kind of coded it all out with that big for loop and stuff like that. Syntax of a for of loop. Do a for, value initialization of the array and the statements. So declare a variable, it's a let, give it the name sum, assign it the value of 0. So for let value of totals, value holds the current value, and then sum plus equals value. So it's just taking those values and totals and adding them up. So pretty close the same way as doing that, but you just call it a little bit different. Here you're calling each index from the array. Here you're just taking those values out of it like that. So you can see it's pretty close to the same, just wrote a little bit different. And in terms related to arrays, element, length of an array literal, index for an array, for in statement, for in loop, for of statement, and a for of loop. There's the test score application printout, code to do it. So that's it for chapter 3, essential JavaScript statements. And like I said, this is all pretty much just a refresher of what we did in the first half of the C# class. You know, it's covering the if statements, the for loops, the do while loops, the arrays. I think what arrays was chapter 8 in C#. The for loops and the if statements, that was like chapter 4 or 5, maybe 3, 4, or 5 in C#. So yeah, so like I said, once you kind of learn one of the language, a lot of it will carry over into other languages, especially like the if statements, the for loops, arrays, stuff like that carries over into most all languages. Python, Jason, didn't you say you used Python before?
I used it, yeah.
It's pretty close to the same thing, isn't it, with the if statements and the for loops and all that. So yeah, Java's the same way. This will all carry over into Java if you decide you want to learn Java down the line at some point or another. Once you learn the basics of these languages, most of them will carry over into other languages. So, and I think that's why some of the people that took the HTML and that class, the people that took this class in the fall and then took C# in the spring, that's why they had a little advantage over you guys. Probably not you, Jason, since you had some programming experience before, but why they had a little advantage over you, Dominic, because you hadn't had a language before. They at least got introduced to this a little bit. And so when they came into C#,
Yeah, everybody made the part of it. It's like, yeah, we know what we're doing.
Yeah.
Enjoying it, yeah.
Yeah, so they had already gotten introduced to, like I said, variables, if statements, and that. So the first part of C# was just a little bit of a refresher for them. That's why the first part of this JavaScript is just a refresher for you, because now that you've already seen the language and worked with it, it's just kind of a refresher at this point. And like I said, they were good up until we got in deep into methods, and that's when they kind of started falling apart. So go ahead and stop the recording here. I'll save and put on a